If we're given with a piecewise function g of x equals 1 if x is less than or equal to less than -1, g of x is x plus 3 if x is greater than or equal to -1 but less than 2, and g of x is x squared minus 2 if x is greater than or equal to 2. What is the limit of g of x as x approaches -1 from the left? So how are we going to solve this? So since we are going to -1 from the left, we should substitute the value here in this part, because from the left of -1 are values less than -1. So when x is -1, then this is still 1. So how about if you are from the right? Limit of g of x as x approaches -1 from the right. So from the right of -1 are values greater than -1. So values greater than -1 belong here. So we have to substitute to this. So that is -1 plus 3. So that is positive 2. So just replace x with -1, copy plus 3, and -1 plus 3 is 2. Since these two are not the same, the number 3, the limit of g of x as x approaches -1 does not exist. How about the limit of g of x as x approaches 2 from the left? So values from the left of 2 are less than 2. So less than 2 are here. So we have to substitute here. So that is 2 plus 3 for x plus 3. But x approaches 2 from the left, so replace x with 2. So 5. Number 5, limit of g of x as x approaches 2 from the right. So from the right of 2, like 2.1, 2.01, 2.001, are values greater than 2. So we have to substitute here, because greater than 2 or from the right of 2, the values are greater than or equal to 2. So substitute here. So we have 2 squared minus 2. 2 squared is 4, minus 2 is 2. Since these two are not the same, the limit of g of x as x approaches 2 does not exist. How about if you have limit of g of x as x approaches 0? So where will you substitute here? So you just need to substitute to where 0 belongs. Where does 0 belong? Less than -1? No. Greater than -1 but less than 2? Yes. So replace x with 0. So 0 plus 3, so that is 3. So the limit of g of x as x approaches 0 is 3. So you have to check the values here where they belong and you substitute there. We are given here with the function f of x equals x plus 2 squared plus 1 if x is less than -2. F of x is x plus 1 if x is greater than or equal to -2 but less than 1. And f of x is 0 if x is equal to 1. And f of x is -2 if x is greater than 1. What if we are asked to find the limit of the function f of x as x approaches -2 from the left? So from the left of -2 are values, so if this is the line, -2 and 1. So from the left of -2 here are values less than negative 2. So less than negative 2 is here. X is less than negative 2. So we need to substitute it here. We need to substitute negative 2 here. So what will we have? So that is a negative 2 plus 2 squared plus 1. So negative 2 plus 2 is 0 squared plus 1. That's 0 plus 1, that is 1. So this is 1. Okay, how about if we have a limit of f of x as x approaches negative 2 from the right? So if you're from the right of negative 2, so you're going there, so you are going to have values greater than negative 2. So greater than negative 2 is here, so we have to substitute here. So x plus 1 is negative 2 plus 1. So negative 1. So this is negative 1. And then, since these two are not the same, then the limit of f of x as x approaches negative 2 does not exist. Okay, how about the limit of f of x as x approaches 1 from the left? So from the left of 1, are values less than 1. So values less than 1 here are here. So we need to substitute here the 1. So that is going to be 1 plus 1. So that is 2. Number 5, limit of f of x as x approaches 1 from the right. So if you're from the right of 1, you're going to go this way. So the values here like 1.1, 1.01, 1.001 are greater than 1. So if it's greater than 1, we have to look at this. So this is equal to negative 2 because there's no x there. It's a constant function. So this part is constant. So this is always negative 2. And these two are not the same. So if they're not the same, then the limit of f of x as x approaches 1 also does not exist. Okay, so this is how you find the limits, the two-sided limits and the one-sided limits if you're only given with the equation of the function. So you have to look at these parts here at the domain. If it's from the left of negative 2, so less than negative 2. From the right of negative 2, so greater than negative 2. And then if these two are not the same, does not exist. Here, from the left of negative 1 are values less than negative 1. So this part here, so substitute here. And then for, if you approach 1 from the right, then you will have this one. Okay, so the values from the right of 1 are greater than 1. So negative 2. And they are not the same, so does not exist.